All right, so I'm trying to compute the area in between these two parabolas. One is facing to the left and one is opening to the right. Notice that the parabolas are just the flips of each other. I mean, the second parabola is negative the first, so I have some symmetry here. This is all, written in terms of functions of y. If you prefer to just switch the roles of x and y, that might help put it into more familiar territory. So I've drawn a typical rectangle here that, from the idea of the section, represents the typical Riemann, the typical rectangle that goes into the Riemann sum, that is the integral of the top function minus the bottom function, which in this case is the right function minus the left function. So if I want to compute this area, I can compute the integral of the top minus bottom, or in other words, right minus left here, since it's in terms of y. And instead, I'm just going to use symmetry to compute the purple area. So right now, I'm finding the appropriate y bounds of the integral, and I'm just going to double the purple area that I see here. So I'm going to double the area under 63 minus 7y squared. And there's more symmetry that I can notice. I can actually just integrate from y equals 0 to y equals 3 and in turn double that. And that's going to be sort of the easiest computation to get at this area. So from here, I'm just using the fundamental theorem of calculus, getting an antiderivative, and then plugging in the appropriate quantities. You do want to do, a reasonable amount of this by hand, and then, possibly go to technology to help. The numbers here aren't so bad, so I could compute it by hand, but it's a good idea to plug your integral into Wolfram Alpha and verify that you got the right answer. So I did get 504 by hand, and so I'm confident that I have the right thing. So now for the second problem, I want to use the same idea of area in between curves to try to find the area of a triangle. Now, there's no sense in trying to proceed with this problem unless you have a picture. How do you know what functions you're using unless you draw a picture, like which one's on top, which one's on bottom, and so on? So I'm just drawing the triangle that they're talking about, and I'm trying to interpret the area in the triangle as a top function minus bottom function integral. So the top function is broken into two pieces, and I'm just going to proceed with labeling all the pieces here. The bottom function is just one line, 2/5 x. But once I have formulas for each of the lines, then I can compute areas by using top function minus bottom function integrals. Okay, so the problem is that the top function is broken, so I'm going to have to do this in two steps. The area in the triangle is going to be first the area from 0 to 3 of the 5/3 x top function minus the 2/5 x bottom function. That's one integral. And then the second integral is going to have a different top. It's going to be from 3 to 5 of the negative 3 halves x plus 19 halves function minus 2/5 x. So from here on out, I just need to use the fundamental theorem of calculus, get some pretty easy antiderivatives, and then since I've got annoying fractions here, obviously I'm going to use technology like Wolfram Alpha or a calculator or something to help me compute. Notice how I'm staying very organized. I see a lot of you when you're doing these computations, you're sort of doing some computations in your head, writing all over the place, and it's easy to make mistakes. You can get lost in your own work. So I recommend just getting, a lot of white paper and writing everything out so you don't have to spend time redoing it. Anyway, I got 19 halves as an answer, and I'm checking in Wolfram Alpha. I'm plugging in the integral, and let's see here, hopefully gives me the right answer of 19 halves. There you go. Yeah, so it interpreted the integral correctly, and it gives me 19 halves as an answer.